Topic B, user input. Now, user input is a very, very useful Python function. You basically set a variable to be equal to input, and that allows the user to type the input into the program, and that whatever the user types in is then saved as that variable. And better yet, the execution of the program is just kind of halted and waiting for the user to enter their input. The input is always, even if you type in numbers, it's always saved as a string. So here's an example. So you can declare message equals to input, and then when the program executes, you can type in the message, Peter, Piper, peck of pickled peppers, and then when you print out the message, you're going to find out that what you typed in has been saved as the message. So let's have a look at this in code in PyCharm and create some programs using user input. In this program, we're going to take a practical look at inputs, and we are going to save inputs initially as strings and then as integers and do some computations with them. So to set up the scenario, it's going to be a very basic chatbot. It asks the user for their name, and then he asks the user for their age, and then makes some comments. So we're going to say, user, next year you will be, and perhaps we're going to maybe even do a variable conversion and say, oh, your age in binary is some number. So let's get started. So first we're going to print something like, hello, human or user, you're human. What is your name? And we're going to save that as an input. Name equals to input. So whatever we type in after this text comes is going to be saved as name, so that we can say print hello name. Now let's run this. And as you can see, the program is just waiting, and it'll wait forever until you type your name. And if I say Bob, and it'll say hello Bob. So next I'm gonna try to save age, and I'm gonna do this imperfectly and leave you guys with a bit of a challenge. So it's gonna be another one of those pause scenarios. So I'm gonna say print so name, not capital, how old are you? And here we're going to save age as inputs. Now we're going to comment print so next year you will be age plus 1. Alright, so I'm going to run this. As I said, it's going to come up with an error, and then when you see it, you can try to fix it yourself before I go ahead and do that. So run. I'm going to try this again. Bob, how old are you? Bob's 30. And we have error. So next year you'll be age plus 1 must be string, not int. Well, well, well. So I will ask you to pause right here and then see if you can fix it yourself. Okay, so here's what the issue is. It's actually saying that the age should be, that 1 should be a string, not an int. That's what it's referring to, because then it would add them. However, age is basically a string. So whatever number you entered is like, it's under quotation marks. So there's a couple of things you can do here. We can basically, after that, convert age into int age. And this should work. Hello human, what is your name? Bob. Let's go for 7. Next year you will be 8. Now you should know that there's also a bit of a shorthand in doing this, and I'm just going to copy this whole print statement here. I'm going to copy and I'm going to paste it in there, and you'll see it's going to run almost exactly the same way, except that this time you'll be entering your name on the same line. So Python allows you to basically put into the input whatever the question is going to be that's asking you for the input. So I'm just going to run it and show you. See, hello human, what is your name? And here if I say Sunyan, that's how it works. Okay, one more fun thing. I thought it'd be cool to add age in binary. Print. So we can actually have a new variable, call it bin age, and that can be the binary version of age, and we can print. You should know that in binary should know that binary is age. So let's check that out. run. Let's be Bob again. Bob 7 next year 8. So there it is. You should know that in Python, when you use the bin converter, the first two are always going to be 0b, and this is the actual binary value of 8, which is 111. All right, that wraps it up for this video. See you in the next one. So in this last program of the lesson, we're going to combine these integer operations we saw in the beginning together with user inputs and create a program that takes in an integer, which is a number of days, and returns out how that works out in weeks, years, and the remainder of days. So let's get to it. So the obvious starting point for this program is to get the number of days from the user. We're going to use the input. That's going to convert whatever the user types into a string. So we're going to have to basically convert that back to an integer. So let's start with that line. So we're going to ask the user for how many days they'd like to enter. Print, enter the number of days. We're going to say days equals to inputs. Now, if we want to convert that to an integer, we can do that on the same line or on the next line. Since we did it on the next line in our previous program, we can do it on the same line here. So here we go. We're going to ask for the number of days. We're going to save it as that variable, convert the string to an integer, and now we can do a little calculation for years at least. So we can now say that years are going to be equal to days divided with no remainder by 365. So we can print years just to test this out. So let's run this. Enter the number of days. So I'm going to say 77, and that should print 0. But if I run it again and then just say, 900, that's going to be 2 years, because 900 can be 365 can fit in there twice with no remainder. Cool. Okay, so let's work out weeks. So when you divide days by 365, obviously this is going to give you, this division with no remainder is going to give you years. But you can also get the remainder. And the remainder is going to get you the days that don't fit. Like for example, when we have 900, it'll be 2 years and some number of days. So this is what the remainder would look like. R would be equal to days percentage 365. And that'll give us the remainder. So if we print years and we print you're going to see when we run 900 again that the remainder is always going to be less than 365. So if we enter 900, there's going to be, 2 years and 170 days. So now we can try to work on line 5 and see if we can create a weeks variable that is correct. So all we need to do is divide 170 by 7 with no remainder, and then we're going to get weeks. So what we can do is weeks equals to that, and when you divide by 7 by no remainder, you can have weeks. So let's run that. I'm going to try 900 again. So 900. 2 years, 24 weeks. Okay, so all we need to do is work out days and then make the program a little bit neater. So all we need to do, I guess, is subtract 900 minus 2 times 365 minus 24 times 7. So days, okay, so if this was days, we're using the same variable, days, I guess I can call it remaining, a long variable name, I know. But that can be days minus years times 365 minus weeks times 7. So these have already been created, and now I'm going to print days remaining. Let's run that. So we're going to go for 900 again. So what you have is 2 years, 24 weeks, and 2 days remaining. So we can actually make this look a bit prettier. So say years, weeks, and days. And it should work. Alright, So let's run this, see what happens, and try it out. So enter the number of days. That was our test number. Years 2, weeks 24, days 2. So let's try 364. Let's see what happens and try it out. So enter the number of days. That was our test number. Years 2, weeks 24, days 2. So let's try 364. 0 years, 52 weeks, and 0 days. It's quite interesting because 365 is actually 52 weeks and a day. Okay, let's try some other random number, and I think we can wrap up. 1,000. 2 years, 38 weeks, and 4 days. Okay, so that wraps it up with the programming videos for the lesson. See you in the next one.